Hello, we're going to begin today talking about some basic concepts of logic, and we'll start with what we mean by logical statements. And the first thing we'll consider are what's referred to as TF statements. TF stands for true false. So a true false statement is a declarative statement to which we can assign a truth value of true or false. But you can't have them both at the same time. You can't say a statement is both true and also false. Now, true-false statements are often represented by variables, and we'll be doing that throughout the course. And these variables will often be lowercase letters. We'll have one lowercase letter to represent one true-false statement and a different lowercase letter to represent another true-false statement. Now, connecting the true-false statements, we're going to have connectives. So a connective is a word or group of words that we use to join two true-false statements. In logic, we have these four basic connectives. We have conjunction, disjunction, conditional, and the biconditional. The connectives allow us to talk about simple versus compound statements. If a true-false statement does not contain a connective, it's a simple statement. It expresses one declarative thought. If you have two or more simple statements joined by one or more connectives, then you have a compound state. So let's consider the various connectives that we'll be concerned with. The first is the conjunction. So if we join two TF, true-false statements, by the word and, we can call the resulting statement the conjunction of the two statements. Sometimes the word but is used in place of and we'll come across that in our studies as we move along. The symbol for the conjunction is this caret, and the statement P caret Q is read P and Q, or P conjunction Q. The disjunction joins two true-false statements by the word or, and the resulting compound statement is referred to as the disjunction of two statements. The symbol for the disjunction looks like a V. So we have the statement P, V, Q, and it's read P or Q, or P disjunction Q. Now sometimes we have the word either explicitly or implied in the sentence. Either always goes with or, and the two words are simply represented by one disjunction. The next two connectives are referred to as the conditionals and the biconditionals. The conditionals, we have two statements, P and Q, and they're joined together in the form of if P, then Q. And that's your conditional statement or also implication. The symbol for the conditional statement is the arrow pointing to the right. The statement P arrow Q is read P implies Q, or if P, then Q. The left-hand side of the conditional statement, which we represented as P here, is called the antecedent. The right-hand side of the conditional statement, which we have as Q, is called the consequent. The biconditional is two statements in a very complex form. It's actually two conditional statements joined by the and. Thus, the title, biconditional statement. Because of the rather strong longer notation here, we denote the biconditional P and Q as P arrow arrow Q. One of the arrows points to P, the other arrow points to Q. So we say P double arrow Q is read P. The negation if is not a Q connective. However, so these are the last two value of our connectives. We have the conjunction, or we state the disjunction in a sentence by using the word and the biconditional. Not. And those are the only. Sometimes you may also see the phrase "it is not true that," two or more, or simple the phrase "it is false that," written in front of a statement. That negates the whole statement. The symbol for the negation is a squiggly line tilde, and thus the statement tilde P is read not P. And this symbol is used when we have not, or the phrase "it is not true that," or the phrase "it is false that." Parentheses in logic is very important. When we have more than one connective, the statement could be grouped in more than one way, and thus we have different meanings. So the parentheses helps us to define the grouping and hence meaning that we want from a statement. Okay, so that concludes our little discussion today.